This is the final presentation for Chapter 8, and the last concept that we are completing in this chapter is the concept of empirical formulas. The word empirical simply means determined by experiment or by observation. There are experimental ways to determine the empirical formula for compounds, but we're not going to go into the details of that math. We are just going to discuss what an empirical formula is, what it means, and how you can find it from the molecular or chemical formula of a compound. The empirical formula is defined as the subscripts that express the smallest whole number ratio of the atoms that are present in the compound. And although you can find it mathematically, we aren't going to do that. We are instead going to focus on how to find an empirical formula from the chemical formula or molecular formula. If you know the true formula of a compound, and this is just an exercise for non-ionic compounds, ionic compounds are already in the empirical formula. If you know the true formula of a compound, you can reduce the subscripts if they can all be divided by the same number to give you a whole number. On this slide, they have one example of reducing a molecular formula to create an empirical formula. The molecular formula of the compound is C6H6, 6 carbons, 6 hydrogens. Since the two subscripts are identical, we can just divide by 6 to get the empirical formula of CH. Multiplying by 6 restores the molecular formula of C6H6. So the actual formula of this compound is C6H6. The empirical formula is CH. It's just telling you that the ratio of the atoms C and H in this compound are 1 to 1. Some compounds can't be reduced any further, and so they have the same empirical and molecular formulas. And examples of those are compounds like H2O, where one element in the compound already has a subscript of 1, so you can't reduce that anymore. CH4, again, we have 1 carbon, 4 hydrogens, and NO2, 1 nitrogen, 2 oxygens. Other compounds, you don't have to have a subscript of 1, but if you had something like N2O5, you can't divide 2 and 5 by a number and get a whole number. So that would be another example of a compound that had the same empirical and molecular formula. So it turns out that you can have compounds that have the same types of atoms in them, but they don't necessarily have to have the same empirical formula. So for example, on the top, we see 2 hydrocarbons, C2H2 and C2H4. And these two compounds have different empirical formulas. The empirical formula for C2H2 is simply C1H1 or CH, because we can divide the two subscripts by 2 to get 1 and 1. The compound C2H4, we can also divide the two subscripts by 2, but in this case, C2, 2 divided by 2 equals 1, and H4, 4 divided by 2 equals 2. So the empirical formula for that compound is CH2. So even though the two compounds have the same 2 atoms in them, they don't have the same ratio of the atoms. And empirical formula can tell you a lot about the family of the compound. We're not going to get into that, but it's very useful when working with compounds that have carbons and hydrogens or carbons and hydrogens and oxygens. In the second example, we see 2 sets of compounds where each set shares the empirical formula. The top row, C2H2, C5H5, and C6H6, all have the empirical formula CH. The bottom row, C2H4, C5H10, and C6H12, all have the empirical formula CH2. So even though they all contain only carbon and hydrogen, they don't all have the same empirical formula. Well, I may run out later and get gas. Finally, in this last slide, we'll do a few examples of finding empirical formulas. So on this slide, we're going to find the empirical formula for 4 different compounds listed here: C6H12O6, NO2, H2O2, and P4O10. If you want to try it on your own before you listen to me do the explanation, you can pause the presentation at this point. And if you've decided you wanted to listen to the explanation, you've turned me back on. So let's take a look at the first compound, C6H12O6. C6H12O6, all the subscripts are divisible by 2. They're all divisible by 3, and they're also all divisible by 6. That is the largest number we can divide them all by. So if we divide them all by 6, we end up with an empirical formula of C1H2O1, and we did that example before. Our second compound is NO2, N1O2. Because N is already a 1, and 1 is as low as you can go, we can't reduce this empirical formula any further, so our empirical formula is the molecular formula NO2. Our third compound, we have H2O2. This is hydrogen peroxide or dihydrogen dioxide. Both the subscripts are 2. We can reduce them by dividing by 2. So we end up with H1O1, which is just HO. And our last compound is P4O10. P4O10, 4 and 10 are both divisible by 2. They are not both divisible by 4. If we divide by 2, 4 divided by 2 is 2, and 10 divided by 2 is 5. So our empirical formula is P2O5. That is the extent of the work on empirical formulas that you would be responsible for on the test. That is the last presentation for Chapter 8.